We'll proceed in innovative approach in calculus. We have talked so many things. We have talked so many things about Jacobian. Now I believe it is a valid question that what is Jacobian? What is Jacobian? Okay, to understand what is Jacobian, okay, to understand what is Jacobian, let's understand the need of Jacobian. So what is the need of Jacobian? Let's calculate the surface area of a circle. What is surface area of a circle? Surface area of a circle, probably someone would think about fx dx. If there is a function fx which talks about circle, dx is surface area of a circle. One way. Okay, I have circle. Okay, I really have a circle. What is the surface area of the circle? If I have x-axis, okay, if I have x-axis, this is x-axis, then someone would ask that what is the equation of your curve? This is x-axis. Then what is equation of this curve? What is fx? Function over x, fx, that is y, is the square root of a square minus x square. X square plus y square equal to a square is the equation of circle. In that sense, x equal to x, y equal to square root of a square minus x square. Then simple fx dx, and where x is minus a to a, probably you will get the area of the circle, because if I have a curve and if I calculate integration, it gives the area underneath it. True. Is there any other way to find the kind of uh, area of a circle? Okay, other way is that I can calculate area of a circle. I can calculate area of a circle through calculating the volume of a cylinder. I can calculate area of a circle by calculating the volume of a cylinder. Okay, or kind of what is the area of the circle? If I talk about three dimensions, can I calculate area of a circle in three-dimensional way? 3D, 3D area of the circle. Okay, if I have XY plane, if I have XY plane, on XY plane, circle is kept. XY plane, circle is kept. Okay, what is the area of the circle where x-axis, y-axis, x-axis, y-axis, both are independent to each other? If I talk about two-dimensional x-axis, y-axis, x-axis, y-axis, y-axis is dependent upon x, y equal to function over x. In three-dimensional x-axis, y-axis, they are independent to each other. Z-axis, z is dependent upon x and y. Z equal to function over x comma y. X and y are independent to each other. If I have a surface, any surface, what is the volume of this surface? Like if I had taken a cube, okay, so if I have a surface, what is the volume of the surface? That is under question. So volume, if I say I have fxy, function over x and y, function over x and y, if I integrate with xy plane, fxy dxy plane, f braces x comma y braces close, fxy dxy plane where independent variable is xy plane, fxy dxy plane, dxy plane also we can write as dx dy, dx dy, fxy dx dy. What it gives? It gives the volume under the surface. If this is the surface, then the surface, if I bring it down, whatever the air, whatever the air it is underneath the surface till xy plane full region volume it gives. Fxy, like if fx consider that fxy, consider this is xy plane and this is fxy, that is a flat surface. What is volume of this? If I say fxy is 4 because since it is flat, it has only z component, it is not tilted anywhere, only z component. Now if I say fxy 4, height is 4, so equation of the surface is only 4, z equal to 4. What is the volume? If this is xy plane, if this is xy plane, then if I bring it down, whatever the cube is, it is displacing the air. Okay, so this width, this is the rectangle into this height, it makes a rectanguloid, it makes a cubical region, this much cubical region. That cubical region volume it is calculated. If this surface is lying on the xy plane itself, then there is no volume at all. Okay, so volume is nothing but if I have fxy, what is the volume underneath it? If I have fx and if I calculate the fx dx, then whatever the surface area underneath it. If I have a xy plane here and if I have a surface, here there is a curve fx gives the area. If I have a surface, then surface dx dy will give the volume underneath it. So if I now the question arises, can I calculate the surface area of a circle? Surface area of a circle through 3D. If I want surface area of a circle through 3D, then I can calculate the volume of a surface which height is 1. Okay, so 1 dx dy, fxy dx dy. So if height is 1, underneath it, whatever is the volume, we will calculate. The surface, what we are talking about, it is a circular region. It is not a flat rectangular region. It is a flat circular region. In that sense, if it falls down, then it will make intersection on x-axis exactly like this. If that is the case, then the limit on x and y, when we are calculating the volume of the surface that is at height at 1, that is 1 dx dy, x is from minus a to a, x, x is from minus a to a, and y is minus square root of a square minus x square to plus square root of a square minus x square, minus a to a x, and y is minus square root of a square minus x square to plus square root of a square minus x square. That is the reason on xy plane, that is the limit that we have to place. So x is minus a to a, y is minus square root of a square minus x square to square root of a square minus x square, 1, that is fxy dx dy. It will give the volume of a 3D which is shape of a rectangle, circular, and it is height 1. Okay, if any volume which height is 1, then 1 into the below surface area, that is the volume, right? So 1 is gone, at the end we are calculating the surface area only. This way also we can calculate the surface area, where limit is minus a to a, that is x, and y is minus square root of a square minus x square to square root of a square minus x square, 1 dx dy. This is the also way I can calculate the volume of a circular region of height 1. Okay, so it is a cylinder only. Circular region of height 1 is a cylinder. So cylinder whose height is 1, volume is nothing but the surface area of the circle only. This way also I can calculate the surface area of the circle. Now question arises is, if I do so, then first anyone would point that limit is not perfect. X is minus a to a, that is constant to constant, all right. But y limit should also be constant. That is, the area on the xy plane should be rectangular, not anything non-rectangular. Why you want rectangular? Because y and x and y are independent components. This is what the initial consideration is. If they are independent to each other, then limit should be constant, not y is dependent upon x. This is not perfect. X is minus a to a and y should be something, some constant to constant, not minus a square root of a square minus x square to plus a square root of a square minus x square. This is something, look, funny, dangerous funny. In that sense, what we can do? Anyway, we will solve it. Dx dy. First, we will calculate dy, 1 dy, that is y. Y is from minus a square root of a square minus x square to square root of a square minus x square. Okay, if that is the case, then it will come as square root of a square minus x square minus minus plus 2 square root of a square minus x square dx. This is what I think so. Okay, if that is the case, then 2 square root of a square minus x square dx. Okay, now if someone proceed on this, then what is the integration of a square root of a square minus x square? I don't. What is the square root of a square minus x square? I don't. So person is stuck here only. How he can proceed? Okay, no problem. A equal to r cos theta, y equal to r sin theta, or a equal to or x equal to a cos theta. When you say x equal to a cos theta, you are entering into different coordinate system at all, where the independent variable is theta. So I have fxy, that is 1. Fxy, now this is xy plane. On xy plane, there is fxy, that is the height. Fxy function over x and y is dependent upon xy plane. Now xy plane is dependent upon another independent component theta. Initially, we were thinking that xy is the end and xy are the independent component. But xy plane is again dependent upon theta because I'm saying x equal to a cos theta. If I say so, then a square root of a square minus x square would become a 1 minus cos square theta, that is sine theta. A sine theta. A sine theta, and now dx would become a minus sine theta. A cos theta differentiation is minus a sine theta d theta. A square. Sine, sine square. Now sine square d theta. That also I don't know. What is sine square? Sine square d theta. So sine square d theta, if someone consider, then how much it will be? I believe it is x theta by 2 minus sine 2 theta by 4. This is what I remember. Okay. So, theta by 2. Okay. That will be theta by 2 minus sine 2 theta by 4. Now x is minus a to a. X is minus a to a. If x is minus a, it is very deep. Leave it. Okay, the question is arising that what we can do now. So now our initial limit was x was minus a to a, x is minus a to a, and y is minus square root of a square minus x square to square root of a square x square 1 dx dy. Then altogether I can change into other coordinate system, that is theta r plane. Now it is very simple, right? I know polar coordinate system very well. Polar coordinate system, if my limit is a circle, then theta will be 0 to 2 pi and radius will be 0 to a, that is the radius of the circle, and dx dy I can just replace it by d theta dr. So problem solved, right? Anyway, fxy is 1, it will remain and 1 only. But there is a caveat here. The limit is all right. If limit it belongs to a circular region, I can change theta to 0 to 2 pi and I can change r to 0 to a. But dx dy I cannot directly convert into d theta dr because there is a relationship and that is not a linear relationship. It is not x equal to theta and y equal to r. Okay, x equal to r cos theta, that is polar coordinate. Y equal to r sin theta. If that is the case, then dx dy directly I cannot write as d theta dr. I thought of proving this. This is not an innovative approach, this is done. But so much I talked about Jacobian, I felt rational to prove it. So dx dy, how I can write in d theta dr where x equal to r cos theta and y equal to r sin theta. If that is the case, but I can write dx dy as dxy plane. If it is dxy plane, then I can write dxy plane by d theta r plane into d theta r plane as per simple multiplication division. If that is the case, then it becomes dxy plane by d theta r plane into d theta r plane. Now d theta r plane is the numerator right hand side. That I can write d theta dr, d theta dr. dxy plane by d theta r plane, that is extra that came in the computation, is called Jacobian. So limit x and y are the limit in circular region that happily I converted into theta r. So if it is x equal to r cos theta and y equal to r sin theta, then x and y relationship is a circular relationship because a polar coordinate system. If it is a polar coordinate system, then theta will be 0 to 2 pi for circle and r will be 0 to a, that is radian. Later we will see why it is like that. Nothing can we can imagine, right? That we will see. First tackle this. Then 1 will remain 1. dx dy is dxy plane converted into dxy plane by d theta r plane into d theta dr. This extra stuff came dxy plane by d theta r plane. What it is? Dxy plane by d theta r plane. Okay, what it is? Anyone miss? I don't think it is very difficult to answer. What is d theta r plane? D theta r plane. What is d theta? If I say dx by d theta, then if I say dx by d theta, simply like in a real example, I had to do to calculate the area of a circle, fx dx was the area of the circle a minus x minus a to a. Now fx is the square root of a square minus x square dx. That is difficult, I don't know. If I consider x equal to r cos theta, then whatever it comes, dx cannot I write as d theta. Dx is dx by d theta into d theta. This dx by d theta that is new that is coming is Jacobian. What is dx by d theta? If I have a theta axis and x is a curve, dx by d theta is nothing but if I have a x axis theta axis and x is a curve, then x is function over theta. Indeed, it is function over theta. X is equal to r cos theta, a cos theta, whatever it is. It is a function over theta. If that is the case, then if that is the case, then at any point theta, if this is the x value, function over theta is x value, that is the height. If any point theta, if this is the x value, if I move 1 unit from theta, then what is new x value? Okay, this proves that if I ramp up one unit in theta, then x also ramp up something. For 1 unit change in theta, how many change in height I see? Dx by d theta. Similarly, if I say dxy plane by d theta are plane, theta and r, there are two things coming. If two things comes, it is not a straight line, rather than it is an area. Area. If I take rectangular area, now I have two plane. I have two plane, dxy by d theta. This is theta r plane. This is xy plane. Now how they are related to each other? In xy plane, I have a circle. Okay. And in theta r plane, I have a rectangle. Certainly it is like that only. In xy plane, indeed I have a circle. Okay. The circular region with radius a. But if I say x equal to r cos theta and y equal to r sin theta, okay, if I talk like this, then this would map in theta r plane as a rectangle. Okay, you're talking about rectangle in theta r plane. What is the dimension of the rectangle? Theta is 0 to 2 pi and r is 0 to a. There is a rectangle like that, the xy coordinate to polar coordinate. We'll talk how it is. It is a rectangle, theta and r. If I xy coordinate where there is a circle, if I map it to polar coordinate, then theta is 0 to 2 pi and radius is 0 to a. Indeed, it is a rectangle. Now this axis is theta axis, this is r axis. In theta axis 0 to 2 pi and r 0 to a, this is a rectangle. In theta r plane, if I have a rectangle that maps to a circle in xy plane. If there is a 1 unit change in theta r plane in that rectangle, how many unit of change? Because they are tied to each other. Okay, like simple example is I have a big robot. I have a very big robot, or a robot is working in a kind of uh, uh, metal extraction factory where the metal is getting melted, like iron extraction factory where iron ore is melted. Iron ore is melted, and that heat is so high that a robot is working there. In that case, how I can make robot move here and there? So I have a very small robot in my hand. Okay, if I make the hand move like this, the bigger robot hand moves like that. So this is a controller exactly like that. So it is something like big robot is mapping here. Similarly, here I have a rectangular region and I have a circular region. They are connected to each other. This rectangular region is mapped like a circle on xy plane. This is theta r plane. If I make a unit change in this rectangular area, unit change, then how much unit change in area I see in this rectangle, in this circle, in xy plane, theta r plane. So here the area is area, whatever the area, if I take any rectangle in theta r plane, if I make one unit change, it may grow, it may shrink, doesn't matter. One unit of change in area, meter square, not one unit of change in x-axis and y-axis. One unit of change if I take in the area in the rectangle, if I make change, then how many, then if it grows inside, then the circle will also grow in the side because it is mapped like that. Then how many unit of change in area I see? dxy plane by d theta r plane. This explanation is not available anywhere else. Please do support us. +91 is the India country code. 9483160 is our telephone number. 9483160 +91 is the India country code. Now, I have a rectangle mapped to a circle on xy plane. This is theta r plane. dxy plane by d theta r plane is the Jacobian. If I move one unit in rectangle, how many unit in circle it will move? Where relationship is x equal to r cos theta and y equal to r sin theta. That is under the question. How to find it? Very simple. Okay. Now, if there is a circle, then consider in circle there is a point called P. There is a point called P. And on rectangle, again there is a point called P. In rectangle, there is a point. So P maps to P here. If this P is x comma y, this P is theta comma r. If this is theta comma r, this P is x comma y. Then what is x and y? X is r cos theta and y is r sin theta. Consider x equal to g theta r, any function over theta r. Then y is also function over theta r. Y equal to h theta r. G theta r, h theta r. So that point is g theta r comma h theta r. That is the point P. And here point P. Now in P, I move delta theta. Along theta axis, I move delta theta. The new point is theta plus delta theta, comma r. That is point called P1. If I move so, then there will be a corresponding point P1 here also. That point coordinate is g x plus g theta plus delta theta comma r comma h theta plus delta theta comma r. That is the new point P1. P1 is g theta plus delta theta comma r comma h theta plus delta theta comma r. Now there is another point P2. P2 I moved in r direction. Now new P2 coordinate is theta plus r theta comma r plus delta r. Now there are 3 points. P is theta comma r. P1 is theta plus delta theta comma r. This is not my proof, it's available. And P2 is theta plus r plus delta r. Similarly, mapped point is P1, P2 may not be perpendicular to each other. The way here it is, the way it maps. Now P is G theta r comma H theta r, x comma y. P1 is G theta plus delta theta comma r, H theta plus delta theta comma r. P2 is G theta comma r plus delta r, delta r comma h theta comma r plus delta r. Now we have two vectors. One is p1 and p. If I connect, there is a one vector. If I call it a vector a or p1 vector, p1 vector. Another vector is p2 vector. So p1 vector is nothing but g theta plus delta theta comma r. This vector. Vector means x component I have to subtract, y component I have to subtract. So it becomes a g theta plus delta theta comma r minus g theta comma r I vector. This is a vector, right? Plus h theta plus delta theta comma r minus h theta comma r. This is pp1 vector. Okay. Now pp2 vector. pp2 vector is g theta comma r plus delta r minus g theta comma r I plus h theta comma r plus delta r minus h theta comma r j. Now if pp1 vector and pp2 vector, if I take cross product, then it talks about the area underneath it. Okay, but that cross product, if I take, this area is the delta area that formed because of delta change in the theta r plane. If you watch very carefully, what I did is I had a point theta comma r. I moved delta theta in theta axis. I moved delta r in r axis. I made a delta theta delta r area change. Okay, if I have a small rectangle with width is delta theta and height is delta r, then this area is delta theta into delta r. Because of delta theta delta r unit of change in rectangle in theta r plane, the unit change in the area in xy plane is pp1 cross pp2. pp1 vector cross pp2 vector. If I cross two vector, it gives me the area underneath. So now if I talk about dxy plane by d theta r plane, then d theta r plane I made delta theta delta r change. Because of that, there is a pp1 cross pp2 vector change. That is the area in the xy plane. What is pp1 vector? pp1 vector is g theta plus delta theta comma r minus g theta r. Okay, I plus h theta plus delta theta comma r minus h theta comma r j, that is pp1 vector. Okay, cross pp2 vector, that is g theta comma r plus delta r minus g theta r I plus g plus h theta comma r plus delta r minus h theta r j divided by delta theta delta r. This is what we are trying to get. If there is a one unit of change, but here I made delta theta delta r unit of change. Because of that, that much change in the area I am seeing in xy plane. If I settle it down, then it becomes g delta theta, the first one pp1. Then it becomes pp1 vector, dpp1 vector, okay, by delta theta cross dpp2 vector by delta r, because since it is multiplication I can take this that side. Now the dpp1 vector by delta theta becomes g theta plus delta theta g theta plus delta theta comma r minus g theta comma r I by delta theta plus h theta plus delta theta comma r minus h theta r j by delta theta. If you see this, it is nothing but gx plus delta x, gx plus delta x, g theta plus delta theta, g theta plus delta theta comma r minus g theta comma r by delta theta is nothing but dg by d theta, dg by d theta, where g is x only, x equal to g theta r. So g theta plus delta theta comma r minus g theta r by delta theta is nothing but g theta r by d theta, that is dx by d theta. So dx by d theta I plus dy by d theta j, cross product with similarly dx by dri plus dx by d dy by drj. So dxy plane by d theta are plane. Now x comma y is the point of p in xy plane, that is in a circle. The point was p was x comma y, that was g theta r comma s theta r. So if it is dx by d theta I plus dy by d theta j, that is nothing but dp. So d position, because it can be written as x d of xi plus yj by d theta cross d xi plus yj by dr. That is nothing but dp by d theta cross dp by dr. This is Jacobian. Jacobian is nothing but d Jacobian is nothing but dp, any position vector on xy plane, dp by d theta, dp by d theta cross dp by dr. If someone calculate that this is a Jacobian into d theta dr, net it will be like that. If that is the case, then we can proceed now. Now, what is dp by d theta? P is xi plus yj. Okay, xi plus y. X is r cos theta and y is r sin theta by d theta. Then it becomes r minus sin theta I plus r cos theta j, cross product of now dp by dr, that is cos theta I plus sin theta j. If someone settle down this cross product, it will end up in, I believe, r cos square theta plus r sin square theta, because I cannot cross, I and j will cross, and here j and I will cross, j will not cross. In that case, then it will become r. So Jacobian is r. So net integration is r dr d theta, where theta is from 0 to 2 pi, r is from 0 to a. In that case, r square by 2. R dr is r square by 2. R square by 2, r is 0 to a square by 2 into d theta 0 to 2 pi into a square by 2. Pi r square is the area of the circle. Okay, now next thing that is remaining here, how I can change, thinking it since it is polar coordinate. So x is minus a to a, y is minus square root of a square minus x square to square root of a square minus x square. Silently I convert it to theta 0 to 2 pi and r is 0 to a. This is also not available in any of the book. Please do support us. +91 India country code 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Please do support. It helps. Anyway, now how I can change this integral? This is limit. That is x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square. And consider, I'll take half of it. Y is 0 to a square root of a square minus x square. Now, if that is the case, then y equal to, first is y is 0. If y equal to r sine theta, y is 0, then r is also 0. 0 to a square root of a square minus x square. Y equal to a square root of a square minus x square. X square plus y square equal to a square. A x is r cos theta, y is r sine theta. That is r square equal to a square. R equal to a. R equal to a. 0 to a. Simple, right? 0 to a. Now let's tackle down Mr. X. Minus a to a. If that is the case, y equal to r cos theta and x equal to r sine theta. Y by x equal to tan theta. Theta equal to tan inverse. Theta equal to tan inverse y by x. Tan inverse by y. Tan inverse y by x. Okay. If that is the case, then y equal to square root of a square minus x square, one limit, or at on x axis y is 0. Anyway, it will be 0. But anyway, tan inverse y by x, y is the square root of a square minus x square. That is the case. If x is minus a, then it becomes 0. 0 by minus a is minus 0 kind of scenario. That minus 0, if I say, that resolves in pi. Tan inverse minus 0, that is pi. Okay. What is other limit? Other limit is the square root tan inverse y by x. Y is the square root of a square minus x, or whatever I take, by a. That is 0 by a, that is 0. Pi to 0. So theta is pi to 0. Theta is pi to 0 or 0 to pi, whatever someone takes. So 0 to pi, and r is 0 to a, but r I had taken only half, if someone remembers. It was actually minus a square root of a square minus x square to square root of a square minus x square. I took from 0 to square root of a square minus x square. So whatever comes, probably I would double it. So theta is 0 to pi and r is 0 to a. If I try to double it, then theta I can make 0 to 2 pi. Same thing it will come. 0 to 2 pi. Not happy. Someone would say, I am not happy with this. Okay, if that is the case, if there is a circle like this, if there is a circle like this, then I can say A is not minus A to A. A is 0 back to 0, because it's closed loop, right? A is 0 back to 0. If that is the case, then y is 0 to a square root of a square minus x square. Then y lower limit and higher limit will not come. This much, only 0 to higher limit. And x is full round it will make. If that is the case, then 0 to 0, back 0 to 0, tan inverse 0 to 0 means 0 to 2 pi. So theta is 0 to 2 pi and r is anyway 0 to a. Now it is satisfiable. So this is the way we set the limit. So now it becomes pi a square. Okay, so this is the calculation of Jacobian. If I get something more innovative that we have done, I will bring into the picture. Otherwise, it is something like innovative approach we can close down and we will start vector fundamentals. That is very important, especially in the artificial intelligence. Vector calculus. So that we will see, one or two sessions we will take, not much. Then we'll see what we have to take. So that we will see.